Hi everyone, I'm Anita Burney, the moderator for today's webinar, and on behalf of the Open Source Satellite Programme team, I'd like to welcome you to this webinar, 7 Things You Need to Know About the Open Source Satellite Programme. I say 7 things because as we've been talking to people about what we're doing, these are the questions that we've been asked most about, and hopefully the people who are joining this webinar will find them interesting to know about too. We do have the question panel open, so if you have any questions as we go through the material that you'd like extra answers to, add your questions and we'll be compiling a list of anonymised questions and answers at the end of the webinar. So I'm today's moderator. I'd like to introduce you to today's presenter, Dr. John Paffett. I can't do justice to him in the short amount of time that we have on today's webinar. I'm just going to describe him as an accomplished space business creator and the founder of KISP and the founder of the Open Source Satellite Programme. Welcome, John.
Thanks, Anita. As this is the first of what will be a series of webinars, I thought we should start by providing a very top-level overview of what we're looking to do and why we're looking to do it. I started in the space industry nearly 30 years ago, enticed by the idea of building spacecraft and actually a vision of making space more accessible. At the time, space programs were large and complex. There were only a few countries that were involved. And I was fortunate to get involved with an organization that was trying to make space more accessible and reduce the barriers to entry so that more people could get involved. We made some really remarkable achievements in that time, and space is certainly much more accessible today than it was back then. But I'd say we've still got a long, long way to go. And that's actually one of the reasons why we went off and set up our own company as a way of continuing to stimulate the use and exploitation of space, but also encouraging that to be done in a responsible and sustainable way. The space industry, the applications and services are still very much in their infancy. And I think it's analogous to the days of the Model T Ford with the automobile industry and the Wright brothers with the aviation industry. We think about space as being something that's mature, but it really is not. And that's one of the reasons why we set off on this program, really to try and find a way of stimulating and growing the market that we see today. Today, I thought we'd look at why we're doing this program, our vision for what we're trying to achieve, our goals and our pledge. We'll take a look at the perspectives from different users. It's too easy as a technology company to think it's all about the engineering, when in fact it's the use, the applications and services that are really the important factors. We'll take a look at the timeline for the first mission and where we want to take it from the future. We'll then take a look at how we're trying to make the information accessible and how people can get involved.
So, I mean, that's an interesting question, John. I mean, why start this program? There are lots of people in the industry who think there are loads of satellites already. So what makes this different from what everyone else is going to be doing or is already doing?
So when I started, say, a little over 30 years ago, space programs were large and complex and I'd say expensive. So they were only really being performed by a number of small space powers or space powers. So you can think of the US, the Soviet Union, Europe, China, for example. So there was a certain price point which programs had to, which programs cost before they could either get a spacecraft launched and operated. So it's very much a barrier, and so the number of spacecraft that were being launched were very, very few. And a couple of organisations recognised that problem and set out to find different ways to overcome those barriers, looking at ways in which they could reduce the price of space-based systems. And I was fortunate enough to be involved with one of those entities. And so we looked at, could we take a different approach to the implementation of space-based programs? So rather than using what we call space-qualified devices and very large-scale space-type processes and standards, we looked at whether or not we could exploit capabilities from other markets and other sectors. So, for example, we were using components from the electronics industry, so from mobile telephones, the automobile industry, from the computer industry, and that enabled us to radically reduce the price point of small spacecraft. In fact, when we started, people were in complete denial about the need. I remember one of the biggest challenges we had was convincing people that you could do useful things with small satellites. In fact, I'd say for the first 15 years, it was an uphill struggle to convince people that you could do useful things. We had success. We were able to capture customers around the world, but certainly a lot of the community looked at what we had to offer and believed that it was only really for sort of experimentation and demonstration purposes. It didn't really see any operational utility. But I'd say in the last 15, nearly 20 years now, that pivot point has been reached, and people now really appreciate that you can do really useful things with small satellite-based solutions. So the utility and application has been demonstrated in the market, pretty much exploded at that point. And that led to another area of development. There's a group in the US that believed that the price point of satellite-based systems could be reduced even further. So they set out to develop what they called the CubeSat standards. These were 10 centimetre by 10 centimetre by 10 centimetre tiny spacecraft, with a vision that any school or university or even club could afford to design and build and launch a spacecraft of that size. And that really reduced the barrier to entry for space-based systems. One of the challenges of that size of spacecraft, though, is the physical accommodation, the form factor. So yes, you can get into space, but you can't break the laws of physics. There's only a limited number of things that you can cram into a package of that sort of size. Interestingly enough, if you look at that trend, you see that it's pretty much followed on this line, this price performance point line, as it were. And so you look at that and you see that trend as people have sort of tried to come down in size to address that bottom end of the market and really make space more accessible. But the one thing we'll notice is there's that gap in the middle, and we see that. We're a system design, system engineering house, and we are routinely coming across customers who have a need for something that's more performant than a CubeSat, but want it to be at the price point of a CubeSat. So there's clearly a market need there. And what we've seen in recent years is the small sat community trying to come down in price. So trying to maintain a level of performance but reduce the price point further. We're seeing the CubeSat community coming up in size slightly, again trying to maintain the right price point. But these are what I'd call incremental improvements, not revolutionary improvements. And so what we're seeing is a need to depart from that line, as it were, and to do something different. So we identified as a company a need for a much more performant, what we'd call a next generation microsatellite platform. So something that is the price of a microsatellite, but at the price point of a CubeSat. And so there's definitely a market need there for something in the 25 to 250 kilo class, 5 to 7 year lifetime in both benign and harsh environments. There's clearly a market need there. And so that's we identified that need and set off on the development of this next generation microsatellite platform. One of the key drivers of the company, though, is to look at how we can really stimulate the use and application of space. So for us, it wasn't enough to think, well, let's develop a product that fulfills that market niche. But we also wanted to see whether there are other ways of doing it. Although I would argue the space industry is very much in its infancy, I'd say sometimes we do adopt quite old and antiquated business practices. There's a certain element of IP protectionism, as it were, still very close and guarded, very much niche type of behavior. And so we started looking around and going, okay, well, we could develop the product ourselves, but is there a different way of doing it? And for that, we started looking across into other sectors. And was looking at what's been happening in things like the software industry and the maker electronics community. And what we've seen is a massive growth of capability in both of those areas, really driven by things like the open source approach. And so one of the things that we started to explore was, could we adopt the open source methodology or approach and apply that to the development of a next generation microsatellite platform, and actually use that to really improve the price performance point and the accessibility of small based satellite systems. So that was really the genesis of why we started the open source satellite program, was to, but one, address a market need for a new reliant, agile, performant, reliable 25 to 250 kilo microsatellite platform, but at the same time embrace a different way of working and a different industrial approach to make that happen.
So it sounds as though, John, that there are two elements to what we're trying to do. Could you knit that into, an overview of what the vision is for the webcast attendees?
Yeah, absolutely. So as I was saying earlier, if I go back to what's our vision as a company, say I describe ourselves as a project engineering company. It's a little corny, but I talk about turning ideas into reality. We find ourselves surrounded by some brilliant people with great ideas, but not necessarily knowing how to implement those ideas, or needing help and assistance in the implementation of some of those ideas. So as a company, that's what drives us, is to help people implement their visions, as it were. As an organization, we're striving to make space more accessible. So that's very much at the heart of what we're trying to do. We're trying to stimulate the use and exploitation of space for people to develop new applications and services, but we're also looking to promote the responsible and sustainable use of space as well. And we've seen a massive growth in the number of different applications and services that people are looking to use space to address in the last 5 or 10 years, and that growth is continues to be phenomenal. In terms of this particular program, we're looking to embrace the open source principles and philosophy to develop this, say, 25 to 250 kilo class, fully open source platform, and to make that design readily available as a foundation on which other people can build. And the thing that's important for us is we're not paying lip service to that goal. We're actually trying to implement it in a very robust way. So we want a platform that is performant, that is capable, that's modular, that is a real solid basis upon which people can build. But we also acknowledge that space really isn't a commodity market. Each of the applications and each of the payloads, they're very different, and so you need something that can be easily and readily tailored and adapted to fulfill a particular need. And so that's very core and at the heart of what we're trying to achieve. We're also looking at how we can make use of commercial off-the-shelf capabilities, whether that's parts or processes or tools. We want a solution that is accessible, that people do not have to make huge amounts of investment in order to take that, leverage it and exploit it. So the use of COTS is important to us as well. But we also want a platform that can be upgraded and reconfigured to some extent when launched. So being able to modify and adapt the software on orbit, for example, to be able to take account of lessons learned from its operations, or to be able to evolve as the applications and services need to evolve. We want a solution that can be that is not bespoke and needing custom ground infrastructure, something that can be operated with a multitude of different ground operations and networks. But most of all, we want a design that's available for all. So how to memorialize the design so that people can take that and exploit that in the future. And we're hoping that actually this is a way of raising the bar in terms of the capability point, so that people can then use that as a launch pad for future programs, as it were. Key thing for me, though, is the pledge of what we're trying to do. One of the questions we often get asked when we start talking about open source is, oh, so you're going to make the software available, how useful is that to us? Well, you go, actually, this is not just about making the software available. Our pledge is to make all of the satellite platform design information available. So the parts list, the schematics, the PCB layouts, the mechanical drawings, the source code, the firmware, the application code, basically to make all of the satellite platform information available and accessible, freely, openly accessible to the wider community. So our pledge is that within a year of the first launch, all of the information in its native formats will be available for people to take and use and exploit. We will be making information available prior to that date through the website and the repository, which I'll come back to later, but also to the supporters and the sponsors. We have a growing interest with some of the sponsor community who are interested in getting access to the design information earlier so that they can leverage the capability even before the first launch, which is very exciting. So again, our pledge is to make that information available and accessible so that people can take that and build upon that in the future. I mentioned at the very beginning about the need to consider the varying different stakeholders' perspectives. This is something that we've been spending quite a bit of time on recently, looking at what this satellite platform needs to do from a number of different perspectives. So, as I say, as an engineering company, it's too easy to get sucked into the technical detail and get fixated by how much memory the onboard computer's got or how fast the processor is. Actually, for many of the users, they really don't care. The platform is but a mechanism to perform a mission or a function or to hold a payload in space. So we've been looking at what this program means from a customer perspective. Customers that want a cost-effective, modular, scalable, flexible, robust solution on which they can perform their mission or their program. Lifetime and reliability are very important for many of the community that we're talking to. There was I've heard in a number of conferences recently with people saying that they only need a spacecraft to last for a year. Well, I think what they really mean is they can only afford a spacecraft to last for a year. In reality, many of the applications and services need something that is going to last longer. I mean, if you go and buy a mobile phone or a laptop, you don't say, I only want it to last for a year. You want it to last long enough until you get the next version, and that may be 12 months or 18 months or 2 years. So it's important that lifetime of the satellite does not become the driving factor for what you're trying to implement. And that's particularly the case when you're trying to launch a new commercial service, for example. You need an element of robustness in your business case, and inevitably the service uptake isn't as quickly as some of the customers expect. So lifetime becomes a key factor. We've also been looking at it from the operator perspective. How can we reduce the cost of spacecraft operations? There's no point having a low-cost satellite platform to build that then costs a fortune to operate. So how can we go about being able to operate the spacecraft in a very cost-effective or low-cost manner? We've been exploring it from the payload provider's perspective. That tends to get a bit closer to the sort of technology level, but the payload providers want something that's versatile. Very few of the payloads are identical. Their needs change and vary, so versatility in terms of how it can be interfaced and accommodated, straightforward accommodation, but also a wide range of user payload accommodation options are all important for that community in how they go about accommodating their needs. And then just as importantly is the community. So I mentioned that we're developing an open source satellite platform, but we're also trying to develop that community and a wider ecosystem. So those two things have to go in parallel. We're really keen for community involvement in the development. In fact, we would love to take people's inputs and suggestions into account in the design, or for people to even be involved in the design. And so the development of that community and the community's needs are a critical aspect and something that we are paying a lot of attention to as we proceed with the development.
And that's an interesting time to ask a question about timelines and plans, John. One of the questions I get asked quite a bit when I'm out and about talking to customers and stakeholders are, there's two elements really. What's the near-term timeline for your first mission, but also where is it that you actually want to get to with all of this? These are really great ambitions and great goals, but where do you want to get to at the end of this?
So the goal, the overall, let's call it the overall technical goal of the platform development, is to develop a high performance microsatellite platform that is suitable for operation in a range of different environments. So from low Earth orbit through to MEO, geostationary orbit, and even lunar use, for example. So a platform that can be used in what I'd call harsh and benign environments. And our goal is to reduce the price point of the platform as low as we can physically get it to. Both the recurrent platform design, but also the amount of effort that it takes to customize the design. And one of the things that we've realized is we're not going to be able to achieve that in one go, and I'll come to that in a minute. And so we're breaking the program into a couple of stages, as it were. And we anticipate the launch of, we're focusing our attention at the moment on the development of the first mission. We're aiming for launch in early 2022 of the first satellite platform. And that will be a solution that is highly integrated, will be suitable for 5 to 7 years of operations in LEO, will be able to accommodate a range of different payloads, and so it really will be a demonstration of the capability and the approach. And so we have a timeline for the first mission that sees us proceeding with that design and development work, beginning with the integration in 2021 and testing, and then say launch at the beginning of 2022. We're then anticipating a 5 to 7 year lifetime for the first mission. That first mission configuration we're still in discussions about at the moment, but there's a range of different applications that we're considering at the moment. So we see the first launch, say 2022, and then say all the platform information being readily available at the beginning of 2023. So that's what we're heading towards today. There is an argument that we could accelerate the development, but actually the key thing from my perspective is making sure that the community develops in parallel with the platform development. And so it's really important that we develop the community, that more people are involved in the development and are able to participate or provide feedback or input into that development. And so those two things go really hand in hand. So I think 2022 is a realistic goal for when we should have that first satellite launch, which would be good. I mentioned having to have a bit of a compromise, as it were, and so it would have been great to have got the 100% solution on day one. The reality is that's going to require quite a significant amount of investment in terms of the NRE to get us to the point that we want to get to. And so we're really breaking that into a number of phases, I guess, for want of a better term. So one of the key things with the development is trying to come up with a highly integrated solution. If I look at low Earth orbit microsatellites or small satellites today, I'd say 70 to 80% of the cost is labor. And so if you want to radically reduce the price point, you have to take as much labor out of the manufacturer as possible. So we're looking at how we can go about having a highly integrated solution that requires a minimum amount of labor. So I think that first launch will get us what I describe our 70% solution. So we'll be using commercial off-the-shelf parts and techniques and tools. I mentioned earlier about the need to have a low-cost platform solution, but also a low-cost way to tailor and adapt. So we're adopting things like the model-based system engineering approach. We're looking at how we've got a scalable architecture and solution that enables us to minimize development time when we're customizing missions or missionizing missions, as I'd call it. And so I think that the 2022 launch will get us our 70% solution. We can conceive that we probably end up with a further step where we go to even a greater level of integration, and in fact feed some of the lessons learned from the first mission into the subsequent mission. But from there, I think the next logical step is to go to an even higher level of integration, and we're even considering platform on an ASIC or a chipset satellite, as it were, really driving for the commoditization of the platform. One of the benefits of taking that approach is at that point, we can make it robust for both the benign as well as the harsh environments, and give us a platform that's ideally suited for a whole spectrum of capabilities, which I think is important. So very much a sort of evolutionary plan. I won't call them variants, because the plan is really to evolve the design and feed into that end point. I guess you could argue we're sort of taking an agile approach, as it were, and some of the things are on the sort of the backlog, and we'll come back to address those at a later date.
Yeah. So the two other questions I get asked quite a lot, and I'm sure you do as well, John, is, where can we find more information on what we're doing, and how can people get involved in what we're doing?
So this has been key key thing that we've been looking at over the last couple of months. When we set off on the development, we were looking around at what other open source initiatives had taken place, both in the space industry, but also wider afield in the adjacent markets, as it were. And one of the things that was interesting to see were the ones that had succeeded and some that have failed and disappeared. And for me, making sure that the information is out there and is almost memorialized, for want of better terms, so people can get access to it in the future is important. So we're working towards establishing a repository where all of the information for the satellite platform will be freely distributed. We're actually looking at broadening that as well, so that we are getting inputs in from the wider community, so that the wider ecosystem and other parties who have an interest in both the platform but the wider activities can also make information accessible. So with the open source website, the open source satellite website, we've taken the initial steps with that. We've created an area where we are generating blogs and articles. At the moment, they're very high level and focusing on sort of the overview type activities. As the program progresses, we'll be getting into more and more detail. And in fact, we'll be having some guest articles and blogs written by other people, both about the platform, but also about other areas that are either adjacent to the program or the wider ecosystem. So you'll see that evolve. But also at the moment, there's a placeholder on there for our resources page. And that's where we'll start putting key information for the satellite platform development and the wider area. So as, for example, we move forwards with certain elements of the design, we'll make the information available there. We're looking at doing some work in the short term on processor selection. And the plan there is to make some of the radiation testing data available there as well. So keep an eye on the website, and you'll see as we start to populate that and increase the amount of information we're making accessible. So in the short term, the material will probably be in PDF format. When we've got the first satellite launched, the design information will all be available in its native formats. So whichever PCB or schematic capture program we end up using will make the files available in that format, etc. Same with the source code, so people can take it in its raw format and take that and build on it. So the resources will all be available. In terms of how to get involved, there's no cookie cutter answer to that. We're really soliciting involvement from the entire community. We're seeking sponsors and partners to help accelerate that development. So looking on how people may be able to contribute either financially or with intellectual property that we can use as the basis on which to build. We've got a number of good discussions that are progressing on that front at the moment. We're looking at how the wider community can be involved, and whether that's people contributing to the design of a particular element of the spacecraft, or peer reviewing part of the spacecraft, or even looking at the missions and the applications and services that could be achieved by the use of that spacecraft. We're very much open. And one of the things that we've found through the engagement that we've had so far is each of the solutions is unique. We really need to understand what the what the individual is interested in doing and how they may be able to get involved, and then we tailor the solution based upon that. And I think that really sort of leads me to sort of the end. For us, really, this is an open invite for anybody that's out there and listening today to join us on our journey as we design and launch the world's first open source microsatellite platform. If you want to be involved, if you want to contribute, if you want to sponsor, then please, contact us, and Anita will give you the details shortly of how you can do that. So we're really open to how we might be able to work and engage with people. There is no fixed solution. We have a clear understanding of what we're trying to achieve. We have an outline plan of how we're going to get there, but we acknowledge that we can adapt and evolve that plan based upon how individuals and entities want to get involved.
Brilliant. That was really great, John. It's been great to be involved in this first webinar, and I feel that we've just started to scratch the surface, really, and we've only answered 7 questions, and I know that there are lots of you out there who've got lots more questions, so do please send them to us either via the webinar questions panel or directly to us. This is very top level at this point, but we've got some great engineers in the team who will be bringing on in future webinars to go into more detail about some of the design philosophy and the outcomes of the work as we go along and mature the design. So ask questions and we will be getting around to answer them as we go through the journey to get to the first mission and beyond that towards the 100% solution that we want to get to. So here are the details on how you can find out more and get in touch. The primary source of information is via the website. If you go on there, you'll find a lot of information about our thought process, our philosophy, where we've got to so far, and over time you'll start to see us populate that with a lot more of the detailed design thinking and some of the actual design files. So that's the best place to go. Those of you who are connected with us already on LinkedIn will see that we're pretty active there. We like to post quite regularly and let you know what we're up to, so do follow us on LinkedIn and Twitter, and we'll also be letting you know when the upcoming webinars are going to be scheduled for as well. Of course, you've always got email, phone and post if you want to get in touch with us in those ways, and we'll leave the webinar running for a bit longer so that if you have any questions that come to mind based on what we presented so far, you can post them there. We will collect them all and anonymize them, so don't be shy. Give us any questions and comments on what you've heard today or what you'd like to hear more of in the future, and we'll make sure that we get an answer to you or get more information. So for now, I'd like to thank you for joining, and from John and from me, thanks for participating, and we look forward to having you join us on the next webinar. Thank you.